Hello, I'm Don Plesner with Team AVI. Today we're going to be discussing the ASE F1 Alternative Fuels Natural Gas Certification Test. We could also use this for information for if you're getting interested in doing CNG too. With this test, we're going to be discussing basic fuel and safety information. We're going to be covering vehicle inspection. We're going to be covering equipment inspection and installation today. If you're going to be converting a vehicle, we're going to be covering leak testing and repair, cylinder maintenance and safety, and also system diagnosis and repair, and the performance and emissions aspect of the system itself. So we'll be covering everything in general form. We're going to be covering first and foremost basic fuel and safety information, going down just the safety aspects of everything. First and foremost, I wanted to bring a difference between CNG and LNG. CNG is compressed natural gas, LNG is liquefied natural gas. The biggest difference is on LNG, it has to be stored in like a thermos bottle, double-walled stainless steel tanks. It's kept at 259 degrees below zero. They call it cryogenics. You can't store it long-term in the tanks because as the tanks actually warm up, it'll turn into a gas, increase the pressures, and cause it to vent off. So, and the other thing is, if you're familiar with a thermos, things don't stay warm or cold very long in a thermos very long. So for a long-term storage thing, LNG is not viable unless you're using it every day. The other thing is you need personalized protective equipment for fueling it, for handling the fuel. Since it is 259 degrees below zero, last thing you want to do is, get liquid natural gas on you, which would freeze things instantly. The other thing is you have to use a vaporizer to convert from liquefied natural gas to compressed natural gas, and after that everything is the same as CNG. Moving on to compressed natural gas, we store it in cylinders rated up to 3,600 psi at 70 degrees. It stays at ambient temperature for storage, so from a long-term standpoint we don't have to worry about things going wrong or leaking out or anything like that. It stays basically whatever the temperature is outside, and you don't necessarily need any personal protective equipment for fueling it. Just normal safety procedures for fueling any vehicle that you normally use is the same thing that you would use for CNG. Okay, fuel basics. Now, compressed natural gas basically is methane, which is CH4. Methane is lighter than air, so it's going to go up to the ceiling. So what happens is if it vents or anything like that, it's going to raise, whereas propane stays down towards the ground. So the thing to keep in mind when we're talking anything about the fuel as far as natural gas is anything that leaks out of it is going to go up. The octane equivalent is 120 to 130 octane. From a performance standpoint, for a performance guy, that's excellent. We like it from the performance aspect of it. From an environmental standpoint, hydrocarbons, it is the least reactive with sunlight. So compared to gasoline, gasoline is the worst. Compressed natural gas or natural gas is the best. Natural gas is the way to go from an environmental standpoint. Also, it forms less CO2 when we burn it, which when we talk about fuel economy and European standards, they go by CO2 emissions, not miles per gallon. So if we're actually looking at it from that standpoint too, we produce less CO2, so actually it would equate out to, in a way, so to speak, better miles per gallon. We have more BTU than gasoline per pound. Now, gasoline is a liquid, 45 degrees below zero, total liquid, compressed natural gas, 256 below. So when you try to average it out, when we go to a gaseous state, obviously we can't store it as much, but we do have more energy content in natural gas if we could get it to be on equal terms of gasoline. The ignition point, gasoline ignites at 600 degrees, CNG ignites at 1200 degrees. Need a really good operating ignition system to make it work right. If your ignition system is poor, it'll show up on CNG, and we'll cover that in greater detail later on in this program. It's also a dry fuel. Has no lubricating properties at all, so the use of hardened valves and valve seats are essential, and it is more essential in CNG than it is in regular gasoline engines that we use today. So there's sulfur components in that in gasoline today that help lubricate the cylinder. Natural gas doesn't have any of that to it, so we have to use things to make sure that we're not going to damage the engine without when we use CNG. As you can see by the chart I just brought up here, flammability in air, CNG is a little bit safer than gasoline as far as flammability in air. We have to get to a concentration of 5 to 15% roughly with CNG compared to gasoline, which can go anywhere from 1 to about 8%. Explosivity, there again, how many people have ever taken a match and just tossed it over towards a pan of gasoline and had it light off? That's not going to happen near as much with CNG as it would in gasoline. So natural gas is a little bit safer in that respect, but at the same time, it is still something we have to be concerned about as far as flames and flammability. So it's not a totally safe fuel by any means, but it is a little bit safer than gasoline to use. Okay, general safety. Now, general safety for natural gas. First and foremost, we're going to store it in tanks between 3,000 and 3,600 psi. The thing to keep in mind about that, since it is under pressure, if we get a leak, we're going to end up with some refrigeration or coolness feeling. But the thing to keep in mind is that it is stored at ambient temperature. It has detection fragrance added to it also. So keep in mind that compressed natural gas has an odor to it. If you've ever had a gas stove at home that hasn't lit off, you'll have that same odor. If you have an accident with the vehicle, you have to go through a complete inspection of the fuel system to make sure there are no leaks, no damages to anything. We have tanks that have weight associated with them. We have to make sure that they stayed mounted down, they didn't move, didn't cause any damage at all. Same thing with the fuel system. We have to go through and make sure there are no leaks out of it at all. If you got to depressurize the fuel system before any repairs are done, you want to make sure that there isn't any pressure to the system. Keep in mind, our base system coming out of the tanks is 3,000 to 3,600 psi. Once we're going into the vehicle, we could have pressures as high as 150 psi, depending on the type of system that we have. So if we're going to do a repair, we have to depressurize it properly. And then after any repair to the system at all, have to do a thorough leak test using the proper type of leak detection methods to make sure that we don't have a leak. There again, the problem that we have is that we could have a fire that could develop. Same thing as with gasoline. If we get an explosive atmosphere under the hood or around the vehicle because of a leak, we don't want it to actually, cause a fire and burn down. Vehicle safety should have a visible label in the engine compartment that identifies the vehicle as being CNG fueled. Our fueling connection should be labeled as CNG. As you can see over here, we have our vehicle sitting next to us. It has the CNG label by it. If you have any O-ring that when you service a fuel system that's there on the fitting, you have to replace the O-rings that are there. The O-rings are supposed to be new anytime you break the fuel system loose. All tubings and hoses have to be permanently marked that they're CNG. So same thing as if you're doing stuff with brake lines and brake hoses, same thing with the CNG. They want it to make sure that it has the CNG approval on it for what it's used. And then anytime that you're properly servicing it, you have to make sure that you use the proper personal protection equipment when doing any service to the system. Okay, vehicle layout. Now, I brought up a slide of the Ram 2500 CNG vehicle, but as you look at the system, it shows that the CNG tanks are going to be actually in the bed. The gas tank's going to be underneath of it. We have our fuel fill, which is actually showing where it's at in the fuel door. So now we have our gasoline fill and our fuel fill in the same place, whereas on this vehicle here, we have our CNG to the outside. So at the same time, we have a specialized dash cluster that shows how much we have in our tank, and then we have our compressed gas engine assembly, which has its special hardened valve seats so it can actually operate properly, along with the pressure regulator. Shop safety, when you're going into it, all electrical outlets or anything electrical has to be at least 18 inches below the ceiling. You need to use explosion-proof lights. There again, we want to make sure that there aren't any sparks that could cause, if we had an explosive atmosphere, to go off. You want to consult NFPA 5230 regulations along with your local, state, and federal guidelines as far as setting up a shop to do it. Most shops that are doing repairs right now have been through that, and the one thing to keep in mind is your local fire marshal is the one that has to say over anything concerning regulations as far as what you follow. You need methane detection and additional ventilation to go with it. On the slide I just brought up, it does show part of the detection as far as methane. It also shows additional ventilation that has been put in the roof of this facility where I took the picture. The thing to keep in mind is if methane is detected, you're going to actually have it to where the vent automatically opens and it vents the entire shop, allows the bay doors to come up automatically so we can move 8 times the amount of normal air through the shop to get rid of the methane. So, and this could happen even if you were not at the shop at the time. If the methane detector went off, your bay doors go up automatically, the fans turn on, and it sucks all the air out of so we don't have a fire. No open flame heaters at all. This came from a shop up north, but we have radiant heaters and it's all entirely enclosed, so we don't have any type of flame that could come through. If you're working down in the south, obviously that probably wouldn't be an issue. You can go out underneath a carport somewhere, but where I'm from, up north in Indiana, you definitely need the radiant heaters in the shop. Alarm and safety panel. There again, that's part of the methane detection and part of the ventilation requirements that they have. You're going to have alarms that go off. It shows actually on the pictures there, you have 2 different lights that are going to flash and the actual detection panel that goes off. That's all part of the system that goes in. From a cost standpoint in that, it is going to involve some high investment dollars to be able to get in to do repairs. Keep in mind, if you're working on a system that the tanks are removed from the vehicle or they're vented totally all the way, now you don't necessarily need this stuff to be there. We'll be coming up to doing vehicle inspection and condition in the next segment. Okay, vehicle inspection for condition, suitability, and compliance. Now, this is pertaining mainly to aftermarket conversions. OEMs have already addressed a majority of these issues. So keep in mind what I'm talking about here is if you want to do a conversion on a vehicle. When we go to convert a vehicle, things that we have to keep in mind. Engine condition. The engine has 100,000 miles on it and needs to have some rebuild done to it. You're going to have to do that before you do the conversions. You have the increased weight of the natural gas cylinders themselves. Depending on the type of cylinder that you use, you could be talking of adding as much as 1,000 pounds of weight to the vehicle just for storage of the CNG. Ride height specifications, there again, if I'm going to add that much weight to the vehicle, it's going to affect the ride height. Road clearance requirements, the specification for road clearance, if it's under 125-inch wheelbase, is supposed to be 7 inches with flat tires. So if you're going to store tanks underneath the vehicle, you're going to have to do some measurements to do that. If it's greater than 125-inch wheelbase, now it's 9 inches of clearance. So if you think about a passenger car, I don't know of too many cars that have like 9 inches of clearance if you're going to store it underneath, which means that, oh, you'll be putting it inside a passenger compartment area. So now we have to worry about venting the cylinder if there was something to go wrong that caused the pressures to raise up. So now we're going to have to worry about getting that to where it's not going to vent inside the vehicle. And then the other thing is range requirements. What about the range of the vehicle? What are you designing it to run on? I mean, if you're going to do total natural gas conversion with no gasoline at all, how much range do you need? So that's going to be a consideration of it. And then the other thing that goes along with the increased weight from the cylinders and that, of course, is suspension and handling. So there again, there's lots of things to consider when doing a conversion on a car, and just putting the system on is just one aspect of it. The other part is the additional weight and where am I going to put all this stuff that goes along with it. When we look at cylinders, we have different types of cylinders that you can see. So keep in mind that when we go and start putting the system on, cylinders that we put on are going to be an issue. And when we come to our next segment, we're going to talk about the actual different types of cylinders that there are and what the costs of those are. Now that we're getting ready to do the conversion types of cylinders, the first type of cylinder we're going to talk about is a Type 1 cylinder. Type 1 cylinders are either made out of all steel or aluminum. And this vehicle right here has Type 1 cylinders in it. And as you can see, they're nice and yellow that show that, but they also look fairly large and bulky too. But they are the most inexpensive type of cylinder that there is out there. They are the heaviest though. So, if we go look at considerations on cylinder types, a Type 1 cylinder would be the cheapest way to get in, but at the same time, it's also going to be the heaviest and going to have me to make the most modifications to the vehicle. Now, a little bit lighter, a little bit different type of cylinder would be a Type 2. That's a metal liner with a hoop fiber composite. The biggest difference on that is I just got a little extra protection as far as using the fiber composite on the cylinder, and I can take a little bit of the metal away from the actual cylinder construction itself. That lightens up the weight some. So from a cost standpoint, we just about tripled the cost of our cylinder now. The next type of cylinder is a Type 3. Type 3, we have a metal liner that's completely wrapped or enclosed by a fiber composite. Now, there's two things that go with that. One of the things is when we fill a compressed natural gas cylinder, we get heat. The metal liner on the cylinder helps duct the heat away so you get a more complete fill. So on a Type 1, Type 2, and a Type 3 cylinder, that metal in the liner is going to act as a really good heat sink on it. On a Type 3 type cylinder, the thing about it is we've got the metal liner a little bit thinner, so now we're actually saving some weight in the vehicle, so it allows us to actually have better weight savings. The fiber composite that goes around there is going to give us a little bit more protection as far as durability. And then finally, the Type 4, we have a thermoplastic liner that's wrapped by a fiber composite. Now, this is the lightest, but it's also the most expensive. So now you have cost versus expense type thing coming into play. We have a total plastic liner, and then it's wrapped by a fiber composite. So basically, we went from a 1958 Cadillac to a Lotus that's made out of all carbon fiber as far as weight, if you want to talk performance of a cylinder and relate it to a car. But the thing to keep in mind is the Type 4 is the baddest as far as weight savings and everything. So I wouldn't have to worry too much about necessarily adding a whole lot of suspension modifications as far as springs and that to a vehicle for it. The next slide here shows the different types of cylinders as far as a cutaway. A Type 1 cylinder, the thing to keep in mind since it's all metal, with filling it and unfilling it, all the stress of the cylinder is going to be supported by the metal cylinder itself. In a Type 2, when we put the composite hoop around it, now that cylinder is taking 45% of it. The composite is 55% of the actual stress. In a Type 3, the metal liner takes 20% of the stress. The composite fiber takes 80% of the stress of filling and unfilling that goes with pressurizing and depressurizing the cylinder. The last on the Type 4, the composite wrap takes 100% of the stress that goes with pressurizing and depressurizing the cylinder. With that being said, that allows me to use the lightest weight. Okay, now cylinder valves. We have two different types of cylinder valves that we can come across. One of them is manually operated valves. I don't think I need to explain that too much. Obviously, you're going to have to go out and do it. The other is electrically operated valving. Electrically operated valves are normally closed. They're going to be energized or turned on either by the ECM or the ignition switch. So the thing to keep in mind is if I have an electrical valve, I still have to have a way of manually overriding in case I have an electrical failure if I have to vent the tank. Now, the next slide I brought up is a tank valve wrench. Most manufacturers, unfortunately, use their own methods for being able to put a tank valve in, so you have to have their tank valve wrench to take and change their valves out. The thing to keep in mind about valves, if I have to change the tank for some reason, I'm going to change the valve out. I'm not going to get a new tank with the valve. So the tank valve wrench is going to be something that works really well if it was designed for that valve, so it actually takes it on and off without causing damage to the valve itself. The other thing is the pressure relief device. The pressure relief is what's going to actually come into play if I get too high of a pressure in the tank. Tanks are rated to a certain amount. If my tank pressure exceeds 5,000 psi, I'm going to vent that tank. That way I don't have to worry about the tank exploding. So I have a burst disc built into the valve assembly that allows the pressure to get vented out of the tank if the tank pressure gets too high. The other thing is, if there's an event of a fire, same type of thing. It's going to cause the pressures to increase. Now, the pressure relief device for heat is like a lead plug that melts out and allows the tank to vent. That is going to be between 212 and about 266 degrees. So I have two actual pressure relief devices that are on part of the valve. One has to do with pressure, the other has to do with heat. It's all designed to get rid of the pressure in the tank and allow it to go to the atmosphere. Sure, there's a fire going on, but what would you rather have? A little extra flame or a big boom that can do more damage to people? I think I'd rather have a little extra flame myself. Okay, tank venting. Now, if the tanks are underneath the car, tank venting, no big deal. We can just let them vent. But if it's actually mounted inside a passenger compartment, like behind the back seat or in the trunk area, then we actually have to run vents outside the vehicle. So, venting the tanks outside the vehicle, the slide that I have here actually shows the tank vent coming from inside the vehicle outside, and then it also shows a 90-degree manual shutoff valve for shutting the system off. On this picture, you're reaching through the wheel well right behind the left rear tire to go in and hit the manual shutoff valve. Another type of manual shutoff valve here shows an actual panel. You cannot have them locked. You can't use a tool. You can have it to where it uses a latch to keep it shut, but there can't be anything to lock the panel to get to the manual shutoff. So it has to be a quarter turn type or a ball for the has to be clearly marked with red, blue, or black letters on a white or a silver background. As you can see, this panel here also has gauges on it to show the high pressures and the low pressures of the system while it's operating, and it does include the fill for the vehicle too. So you could have something as complex as what's shown in the slide here. You could have something that's just where you reach through in the fender well to turn it off. Here's another picture showing the manual shutoff valve and showing the accessibility from the outside, again from underneath. But from the outside, basically you'd be reaching through. So if for something was supposed to happen and you needed to actually turn it off, you had a major leak under the hood, you could just reach in behind the wheel there and shut the system off and not have to worry about it venting out. If you were doing an add-on system to it, here's a manual shutoff valve, something as simple as that, just as long as it's a 90-degree type, but this is another type of manual shutoff valve. Now, fill valves and filtration. First on fill valves. All fill valves in North America follow NGV 1 standards. That's clearly marked on the actual filling port itself. They're color-coded for different working pressures. Green is 2,400 psi, blue is 3,000, and yellow is 3,600 psi. The fill has to be mounted to withstand a breakaway force of 150 pounds. The hoses that you use for filling it up have a breakaway support on them that is set at 150 pounds. So it would make sense that this has to be mounted to withstand 150 pounds. If you decide to drive away while you're hooked up to it, at least, it has to be able to withstand 150 pounds of force. That way the hose will break off and then it'll put in the safeties into effect that are built into the hose instead of you breaking off the fill port and now you're emptying a tank that has 3,600 psi in it. As far as filling it, you have to have enough clearance to be able to allow the nozzle to where you can actually hook up to it to hook up on the vehicle. So when you're thinking about where am I going to put this fill valve and doing a conversion, keep in mind I have to make enough clearance to where I can actually fit my fill for going up to plug it up in there. So if I wanted to put it in where the fuel door is, there might not be enough room for this valve to fit up on there, so I might have to put it in some other area, whether it's outside the vehicle on the side or even under the hood. No matter where you put the fill valve, it has to be able to withstand that 150 pounds worth of force. The other thing to keep in mind is you always want the little cap to be able to fit on and go on there to keep all the dirt out so we can actually utilize it properly. On filtration, the main concern about it is moisture and oil from compressing the natural gas. Just like with an air compressor, when you compress air, do you get moisture out of the air? The answer to that is yes. Same thing. The way the compressor works to compress the natural gas, there is always going to be a little bit of moisture there. There's going to be some oil from the compressor itself. That oil gets transferred to the gas, can actually end up in the tank. If we don't filter it out, the tank can then become overfilled with oil and moisture, and that takes away from the fill capacity of the tank. So we use coalescing filters to actually filter out that so we can actually use our maximum capacity of the tank. The coalescing filters allow you to drain out that moisture and oil that came from the compressor from it so it does not get into the vehicle and cause problems with the vehicle. The other thing to keep in mind about filters is when you go to service the filters, you want to make sure that the system has been vented all the way so there's no pressure on it to be able to service the filter. So it is important to make sure that you vent the system before you service a filter. But if all you want to do is drain out the oil and the water accumulation from it, there are drains built in to where you can just open that up and allow it to drain out without having to take the filter off completely. So that's the good thing about that. Next, we'll be talking about pressure regulators. Okay, now we'll be talking about pressure regulators and fuel mixers. First thing I'm going to talk about is the pressure regulators. We have three basic types of regulators that are used. We have a multi-stage system where one regulator takes the tank pressure down in 2 or 3 stages to slightly above or below atmospheric, depending on the engine RPM. Another type is a 2-regulator system. We have a high pressure regulator. It reduces the tank pressure down from about 70 to 180 psi. A low pressure regulator then is going to take it down to, in a couple stages, drops it to just how we measure it in inches of water with a manometer. The next is a single stage system that drops the pressure to about 3,600 psi down to about 40 to 130, allows us to use a valve body and injectors to allow us to inject it into the engine. So depending on the type of system we have, depends on the regulator type system that we use too. This is a single stage regulator here that actually took the system down from our 3,600 psi to a usable pressure of about 40 to 130 psi. Air fuel mixers, we have several different types. First is an air valve type mixer that can be located above the throttle plate, or we have a Venturi mixer which roughly works the same way, but we can make these to be a closed loop system. The way this works is going to be basically on demand based upon how much air is entered in the engine. It goes through the mixing valve and it actually makes a diaphragm move which will allow more fuel to go in according to how much fuel is going into, air is going into the engine. Next, we have a throttle body system, same thing like throttle body fuel injection, except we're going to have a throttle body CNG injector that's going to sit above the throttle plate. We're going to inject the natural gas, and as it goes by the throttle plate, the gas and the air is going to mix together for going into the engine. That is a speed density based system, works pretty much the same way as the speed density throttle body injection systems we had in the 80s. And then most systems today are either multi-point or sequential fuel injection. They utilize a controller that's going to work in conjunction with the OEM PCM for the system operation. Sequential injection is the most current system used, and this is a picture of a sequential type system that can be used on a vehicle, but we have all the components that are there for actually getting the system to work, and then, you the installer get to put this on and go through all the leak checks. Next, after this, we'll be talking about leak testing and repairs. Now, leak testing and repairs. Thorough leak testing is vital in the performance of any CNG system, okay? All leaks have to be repaired that you find. The complete system needs to be tested using natural gas. If you ever have to replace a tank, they have you do some things that'll actually do it to where you can do initial testing without using natural gas, but any final leak testing needs to be done using natural gas at the pressure of the system itself. First type of leak detection that is the most common and also the most popular is soap and water. As long as the soap is not ammonia-based, you can use it on the system. Keep in mind, if it has ammonia base to it, it's going to be a corrosive to the fuel system that you're putting it on, which isn't very good. Picture here shows Snoop Snope. This actually changes color when you have a leak detected, so it also is an additional aid. But if you aren't using, if you're just using like regular soap and water, you're looking for bubbles. As long as there's bubbles, there's a leak, so you don't want to find any bubbles. The next type of leak detection is an electronic type of leak detector that can do hydrocarbons. Here's one here. Basically, it works the same thing as an AC detector. You turn it on, you adjust it, you go around the system. You're looking for it to sit there and beep. So you have different types that are actually out there on the market. Some are as simple as just a beep. Other ones actually go and actually tell you what the concentration is and what type of gas that it is. And then the last one is a high frequency sound detector. You're actually going to put on a headset and go along, and when you find a leak, it's going to give a high frequency type sound that's going to show up in your hearing. That'll tell you that there's a leak there. I don't know about you, but most shops that I work with, I don't think that this would be very popular. I could be wrong, but I think the soap and water is probably going to be the one that everybody uses. If you got somewhere where you can't see bubbles and you know there's a leak there, now you're going to get out your electronic detector to use that. Now, cylinder maintenance and safety. Keep in mind we're going to follow industry standard NGV2 or Federal Motor Vehicle Safety Standards concerning cylinder inspection and safety. All cylinders have to be inspected every 3 years or 36,000 miles, whichever comes first, by a certified inspector. There is regular visual inspection that can be done by normal personnel during servicing of that. The thing to keep in mind, general visual inspection can be done by maintenance technicians, operator, refueling personnel. You're looking for gross problems with the system. Basically, you're going to go, you look, I don't see no damage to the tank, it passed inspection. That's about as much as it is. You're looking for a gross problem if you're doing a visual inspection. So, whenever you do that, if it's in for maintenance, you can do that. You can make a record of it. It's supposed to be maintained whenever that visual inspection is done, but it's kind of a no-brainer. If you can see stuff when you're filling it up, if there's a problem, obviously you're going to say something. If not, you're going to move on. Next, we actually have the detailed visual inspection that has to be done by a certified inspector. Certified inspectors have gone through a rigorous material as far as what it takes to do the inspection. You either pass or you fail on the visual inspection. You have a copy up on the screen now that you can see the actual inspection sticker. All tanks are rated for a period of roughly 20 years. It shows when the tank was produced, when you're not supposed to use it afterwards. Once you get done with the visual inspection, the inspector actually marks on the tank when the inspection was done and if it was a pass. You've got 3 levels of defects. Level 1 is the least serious. It can be returned to service. It's going to be noted what the defect is. If you have a level 2, you're going to go to the manufacturer and say, hey, I've got this problem. Between the inspector and the manufacturer, they're going to determine whether or not we can still use the tank or whether it's going to be rejected. And then you have a level 3. We're going to actually condemn the cylinder, remove it from service. When a cylinder is removed from service, it is going to be made inoperable. You're going to either chop it in half or you're going to drill holes in it so it cannot be used. So the thing to keep in mind is the primary responsibility is the owner of the vehicle to do the maintenance of it. So keep in mind, it's got to be inspected every 3 years or 36,000 miles, and it's the owner's responsibility for keeping and maintaining the records of that. Okay, now we have a video for you to watch concerning more on cylinder safety and inspection.
Compressed natural gas, a standard for safety. In the early 1990s, NGV industry brought together industry stakeholders, research organizations, and regulatory agencies to start the development of a standard for CNG cylinders. The standard was based on existing pressure vessel standards and placed no limitation on materials and methods of construction, considered both internal and external container environments, and most importantly, incorporated a certification process for design, manufacturing, and quality control. The standard ANSI NGV2 is now in its 4th edition. At the same time, the U.S. Department of Transportation's National Highway Traffic Safety Administration published regulations to cover the use of CNG cylinders as vehicle fuel tanks under FMVSS number 304. Regulations covering the fuel system integrity in FMVSS 303 will be discussed when we cover crash testing of vehicle fuel systems. One of the important design considerations for CNG cylinders is weight reduction, especially where large volumes of fuel need to be stored. Weight reduction of cylinders has been achieved by several means and has led to 4 type classifications of cylinders. The Type 1 cylinder is all metal and has achieved weight reduction by using higher strength materials and production technologies. Composite cylinders use a combination of materials for construction. Type 2 cylinders have a thinner metal body and are hoop-wrapped with resin-impregnated high-strength fibers such as glass or carbon. The Type 3 cylinder uses a thin metal cylinder and is fully wrapped, including the dome ends, with the same high-strength fibers and resin. A Type 4 cylinder uses a non-metallic liner and is fully wrapped with resin-impregnated fibers that can take the full stress of its compressed gas. As we stated earlier, the pressure vessel or cylinder standards were originally developed for industrial gas cylinders, not specifically for NGV applications, and they included production tests such as hydrostatic test and leak test of each cylinder and batch tests such as burst test, cycle test, and coating thickness and adhesion test. Many of those tests have been carried forward to NGV applications. Additional design qualification tests were added to address specific NGV conditions, including ambient cycling test, environmental test, extreme temperature cycling, hydrostatic burst test, composite flaw tolerance test, drop test, bonfire test, penetration test, accelerated stress rupture test, permeation test, natural gas cycling test, and the leak before break test. The bonfire test is essentially a fire test that replicates a vehicle fire. The cylinder and the pressure relief device as part of the safety system are exposed to a fire, and the pressure in the cylinder is released by the PRD before any possible failure of the cylinder. The drop test is designed to replicate potential physical impact damage to the cylinder as may happen in a vehicle accident. The cylinder is dropped from a specific height onto the dome in one test and onto the sided wall in another. The cylinder must still pass the designated burst test with no degradation to pass the drop test. The penetration test uses gunfire to replicate through-wall damage in an accident. The cylinder will release the gas at the penetration point, but will otherwise remain intact. FMVSS 303 requires OEMs to crash certain vehicles to show the integrity of the CNG storage system on vehicles. In this video, a crash test for a school bus involves an approved moving contoured barrier impacting the side of a CNG school bus at about 29 miles per hour. To pass the test, there must not be a leak on the fuel system. The next test run shows the rear end impact. The frame of the vehicle absorbs the impact and there is some movement of the fuel system, but as before, it must not leak any of the stored CNG to meet the safety requirements. The safety record of CNG vehicles has been exemplary. CNG fuel systems and cylinders, when designed, manufactured, installed, and maintained by the existing codes and standards, have a history of safe and reliable operation for their expected life. There are well over 130,000 natural gas vehicles operating in the U.S. today. With the expected continuation in the price differential between natural gas and liquid fuels, there will be accelerated growth in the use of natural gas vehicles in the years to come. The safe and reliable compressed natural gas cylinder is an important part of this transformation to natural gas as a vehicle fuel.
System diagnosis and repair. Now, there's three different types of systems out there you can encounter. Keep in mind we're talking about light-duty vehicles only. We're not talking about what you're going to find in medium and heavy-duty. You've got gasoline biofuel conversion, which is gas and natural gas. You got dedicated conversion or OEM feedback control, injected CNG systems, or you've got dedicated fully closed-loop feedback sequential injected CNG. So there's those three different types. And what I brought up here on the slide is actually showing General Motors' dedicated CNG system, and basically it shows where you have the fuel tank, you have the CNG tank that actually goes in. The thing to keep in mind about it is that we have added onto the system dedicated controls or additional to the gasoline system that's on the car. So, system diagnosis. We're going to utilize additional processors, injector driver modules that work in conjunction with the factory PCM. Okay, the PCM diagnostics and diagnostic link connectors are going to be the same. If we added the CNG processor to it, you're going to utilize a laptop or a computer that you hook up with the USB port to do diagnostics off of the added on CNG system. So keep in mind, if I have added a system on, I'm going to be using another protocol for actually going through and being able to get the codes out for the CNG system. The OEM sensors and that are still going to utilize the OEM PCM diagnostic link connector for going and getting the related codes out. So, dedicated system, I removed all the gasoline system that's on the car, including the EVAP, replaced with CNG components. I sent out the actual PCM, and it's been reprogrammed for CNG only. So now I'm actually going to go through the OEM scan tool or generic, hook up to the diagnostic link connector for doing my diagnostics. So on a dedicated vehicle, we've stripped out all the gasoline components, and now we're going to utilize the OEM PCM, go through the diagnostic link connector on that. Service manuals you're going to need for diagnosis. We use trouble tree charts on the CNG systems just like we would on regular gasoline. Most of the systems are designed to run transparently with the OEM PCMs if they're an add-on unit, so we can actually use bidirectional information on the system. So keep in mind that there's transparency on the systems themselves. If we use an injector controller, the reason we use the injector controller is because there's higher current demand on the injectors than with a factory type injector that we use for gasoline. So we have to use the injector controller for that higher amount of current. Troubleshooting, we're going to actually find out what the fuel pressures are, look at the fuel pressures and make sure they're within the realm that they're supposed to be. And then electrical problems, power and ground is going to be critical for making sure that they are actually where they need. Since we added stuff into it, connections can become corroded, loose, whatnot, due to some improper installation possibly, that we'll have to actually do our proper electrical diagnosis on it. Okay, emissions and performance. Now, natural gas has a higher octane rating than gasoline, so ignition timing can be advanced more. So if we're running a biofuel vehicle, there's going to be two different timing advance curves that need to be ran on the vehicle. You're going to have one for gasoline, one for natural gas. Obviously, we have to do this because if we stick with the gasoline timing curve, our performance on natural gas is going to be really poor. So we want to make sure that we have the two timing curves. The other thing is on emissions. Natural gas produces less CO2 compared to gasoline, so our emissions will be greatly reduced. We have less carbon atoms, there's less carbon buildup in the engine, so now it's on almost act as a cleaning. If we have a biofuel vehicle actually going, if we run on gasoline for a while, we could get carbon buildup. By running on natural gas, we're actually going to actually clean some of the carbon out of it. There's less carbon buildup. The nice thing about natural gas, if we go complete natural gas, is we don't have the tendency of the oil to get as dirty because there isn't as much carbon there. We have a slower burn rate, so main and rod bearings will last longer. The fuel is not going to dilute the oil like we do with gasoline, so we can extend the oil change intervals. We are going to have to pay attention to our engine oil to make sure we use the proper type that's compatible with natural gas. Remember the dry fuel part about the lack of lubrication, so we have to make sure our additive package will protect the engine itself from things that will cause it to have accelerated wear that we wouldn't have to concern ourselves with if we were running straight gasoline. Natural gas and gasoline perform roughly the same. With today's computer programs, we can make up for the difference in that to where we actually end up with very similar amounts of performance and also fuel economy too. Most cases, your fuel economy is going to be roughly the same as it was when we switched from 100% gasoline to our 10% ethanol blend that we have today, which, you know, pretty much what they consider negligible as far as the EPA is concerned. Most emissions that we use, same type of catalytic converters in that we use today is the same thing that you'll use with natural gas. We end up with actually cleaner emissions. We have less CO2, less hydrocarbons, so it's actually going to be even cleaner coming out of the tailpipe than what we're used to on a car. This concludes our program on the F1 alternative fuel compressed natural gas. If there's any questions, please feel free to contact us. Thank you for choosing Team AVI for all your needs now and in the future.